Okay, I'm fine. Let us start our today discussion. Before that, in our previous time, we have seen dimensional expression of physical quantities. When we talk about dimensional expression of physical quantities, what is definition as we have seen in our previous time? We have seen in our previous time dimensional expression of physical quantities. So what is dimension of physical quantities or expression of dimension of physical quantities? Huh? What do you remember from our previous discussion? Let, can you say something?
Refers to the contained in it.
Yes, yes, yes.
Refers to.
Okay, refers, yeah. When we talk about dimension of expression of dimension of physical quantity, we are talking about the basic or fundamental quantities contained in it. For example, the dimension of length area means how many basic physical quantities contained in it. Therefore, dimension of physical quantities are expression of dimension of physical quantities are what? The way we express how many basic physical quantities are contained in it. Therefore, dimension of physical quantity expression is the way we find the fundamental physical quantities contained in it. Therefore, all derived physical quantities can be expressed by fundamental physical quantities. All derived physical quantities are expressed by what? By fundamental physical quantities. That means derived physical quantities are expressed by fundamental. In our today discussion, we will see the scientific notation and prefixes. So scientific note, what is scientific notation itself, or how we can write very large number or very small number in short way. How we can write very large number or very short number in short form. So under this one, we are going to see scientific notation. What scientific notation means, as well as we are going to see prefixes. Prefixes is, for example, in your previous knowledge about centi, milli, micro, nano, pico, and etc. So depending on this one, we are going to see prefixes. Okay, we are going to see prefixes. Prefixes is what is the meaning of prefixes. We are going to see in our today discussion. In our today discussion, we are going to see scientific notation as well as prefixes. Therefore, scientific notation is the way we write what? The way we write very large number or very small number in short form. When we write very large number and a very small number, maybe when we use scientific notation, we get or we omit or we advocate some problems which exist when we write very long or very short small number, very long or very short small number. We are going to see. You are going to see. Okay. Scientific notation is, as I have said as introduction, I think it is visible on your screen. Yes, it is visible.
Yes.
Okay, scientific notation
Yes.
is the way of writing a very large or a very small number, and by using power of 10. Power of 10. For example, a large number can be written in form of by using in short form by using power of 10. For example, instead of you write 1 million, you can write 1 million by 10 the power of 6. Instead of writing 1 billion by 1 billion by using power of 10 by using 10 the power of 9. Okay, so such type of way or such type of way is what we call scientific notation. Therefore, scientific notation is the way of writing very large or very small number by using a power of 10. When we write very large or very small number, there are some problems. For example, the problems in using very large or very small number are when we use very large or very small number, there are some problems. For example, the number are long and it takes some to write. Because of this very long, it starts to write. The second one is the numbers maybe take a lot of space. For example, 10 the power of 6 and 1 million. If you compare by writing in large form, it consumes or it take up a lot of space. So to omit this one or to omit this problem, we must use by scientific notation, and errors may easily be made in reading the number of zeros. For example, if you write a lot of zero after a number or after a digit, it may be made an error which is by reading that very large or very large number. Therefore, by using scientific notation, we can omit this what we call what we have raised now, the problems when we write a large number or very small number. Therefore, this can be solved by what? By this solved by writing the big or small number in a form of scientific notation. This problem can be solved by what? By writing a scientific notation. Therefore, in this point or under this subtopic, you must know what is scientific notation means, the definition of scientific notation, as well as the problems occur when we write a very small or a very large number. So this problem can be solved by what? By using scientific notation. By using scientific notation. For example, if you see, if you take the distance between the sun and the earth, it can be about what? About 150 million. 150 million. This is a very kilometer, by the way, a very large number, So by using this one, if you convert this distance in meter, in centimeter, in millimeter, it may take a lot of space. By scientific notation, you can write this distance in scientific notation form, okay? In scientific notation form. For example, suppose the distance from the sun to the earth is about 100 million kilometers, 150 million kilometers. This fully written as, when we write this 150 million kilometers, this distance can take all this space. And the distance can be written in terms of other unit like meter, centimeter, and a millimeter. Also, you can write this distance in form of decimeter. When you write this one, it takes all these spaces, and to read this one, you may make mistake. So to omit this mistake or to save or to take or to write in short form, you must use in the scientific notation. So the number in above example can be written as by using scientific notation. For example, have you seen 1.5 times 10 to the power of 8 kilometer. If the number is very large, start from right and count to the zeros, count to the left one. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. After one digit, if we count, we will get 11, or about what? About 11 in case of meter. In case of kilometer, 1, 2, 3, 4, 5, 6, 7, 8. Have you seen? So when we write this distance, the distance given by kilometer, when we write by scientific notation, 1.5 times 10 to the power of 8 kilometer. 10 to the power of kilometer. So if you compare this one is very in short form, or by scientific notation. Again, if you take by centimeter, again you must start from right and count from left. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 3. So in the distance given above is, when we write by scientific notation in centimeter, 1.5 times 10 to the power of 13 centimeter. 10 to the power of 13 centimeter. So you can write any number which is maybe small or large. You can write by scientific notation. What do you remember in this case again? What you must remember, before decimal point, you have one digit, only one digit. When you write by scientific notation, you must take before decimal unit, decimal point, one digit. For example, have you seen this one? 1.5. Maybe if 2.56, you must write by such kind of font. For example, if such kind of number is given for you, maybe here is Newton, you can say Newton or whatever unit. So if you wanted to write this one by scientific notation, 1, 2, 3, 4, 5, 6, 7, 8. Therefore, 2.55 times 10 to the power of 8 Newton. Therefore, before decimal unit, how many do you have digits? Or how many do you have number? Only one digit number. So when you write, you must remember this one. Again, for very small number is the same is true. For example, 0 point, here is take as point 0, 0, 0, comma 0, 0, comma 1.25. Maybe to do have unit or not, no problem. If you want to write this one again by the scientific notation, you must start from left. For such a kind of decimal number, you must start from left and count to right. Have you seen the difference between them? For very large number, you must start from right to left. For a small number, you must start from left to right. Look, follow me. 1, 2, 3, 4, 5, 6, 7. Have you seen? Before decimal number, before decimal point, we must do have 1 digit. Therefore, 1, 2, 3, 4, 5, 6, 7. Therefore, 1.25 times 10 to the power of not positive negative number. 10 to the power of 7. Have you seen the difference between them? Have you seen?
Yes.
So, writing or by using scientific notation, we can write very large number or very small number in what form? In scientific notation form. In scientific notation form. So the advantage of this one is, one, it may be save for you the space, and it avoid the number of zeros which is occurred when you read the number of zero. When you read, it can avoid the errors which can be made when you read. Therefore, by using scientific notation, we can use or we can write very large or very small number, very large or very small number. I think it is clear for you. It is clear for you. Clear
Yes.
or no?
Yes.
I think it
Yes,
is too
Mr.
clear. Let us see one additional question. Write the following numbers in scientific notation. Have you seen the difference between them? The first one is very large number. The second one is very small number. Very small number. So to write this one, to write, for example, for the solution for A, how we can write for A? How we can write? Or by scientific notation, when we write question A, what we will get? What we will get? No one? Have you seen, by the way? Have you seen? 400 million. Yes?
For the power of 11.
For the power of 4 times 10 to the power of 11. It can be. Let us see. Let us see. Look. 4, 0, 0, 1, 2, 3, 1, 2, 3, 3 centimeter. Count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah. 4 times 10 to the power of positive 11 centimeter. 10 to the power of positive 11 centimeter. What about B? What about B? 0.00, 00, 00, again 00, 0.212 centimeter. What about this one?
1.2 times negative 14.
Okay, let us see together. Excellent for your turn. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah. 1.2 times 10 to the power of minus 14 centimeter. So you can write any number which is given for you by using scientific notation. Scientific notation. Have you seen? Have you seen?
Yes.
Okay. Do you have question on this point? Do you have question? Do you have any question? For decimal number or very small number, you start to count your zero from left and count to right. For very large number or for positive number, sorry, not positive, only for a very large number, you count from right to left. And before decimal units, you must do have 1 digit. If you consider, if you know this point, you can write any number which is given for you by scientific notation, okay? By scientific notation. I think it is clear for you.
Yes.
Okay. Let us see about prefix again. Prefixes. This one is by contextual. We are going to see by the contextual of physics or by view of physics. Maybe prefixes in language maybe to have another meaning. So in case of this one, you must see or you must consider by the view of physics. Prefix in physics is the symbol for the power of 10 are called prefixes. Have you seen this definition? Have you seen this definition? The symbol for the power of 10. For example, you can symbolize 10 the power of 3 by what? By kilo. Kilo. Have you seen? For 10 the power of negative 2 centi. Centi. Have you seen? The symbol for using the power of 10 are what we call prefixes. Prefixes. So prefixes are the symbol for the power of 10. When we use power of 10, we can symbolize or we can substitute by prefixes. Prefixes. So the symbol for the power of 10 are called prefixes. For example, milli, centi, deci, deca, hecto, eta, zeta, and etc. For very small number and for very large number, it continue. It continue for the power of 10. So prefixes, the word prefixes means something put in front of units. For example, kilometer. Let us, for example, I can show for you 1 kilometer, for example, 1 kilometer is equal to how many meter? 1,000 meter. So kilo put in front of meter. Have you seen? In front of meter. For example, kilogram, decagram, milligram. They put in front of units. They put in front of unit. For example, instead of kilo, you can insert again 1 times 1,000. Kilo means 1,000. I have said 1,000. Meter is meter. Meter is equal to meter. Have you seen? They are equal. 1,000 meters equal to 1,000 meters. Have you seen? They are equal. For negative number again, for others negative, let us show for you one. Let us try to show 1 meter is equal to how many centimeter? Or 1 centimeter. 1 centimeter is equal to 10 the power of negative 2 meter. This means 1/100. 1/100. For example, centi means 10 the power of negative 2. Negative 2. Instead of centi, we can symbolize or we can substitute by 10 the power of -2. They are equal. For example, they are equal. For example, they are equal. If you to change each other, they can be equal. Therefore, the prefix means something put in front of units. For example, kilogram, gram, centigram, decigram, decagram, and etc. Kilogram, millimeter, centimeter. They are what? They are they put in front of unit and express that unit or amount of that unit, or to especially to show the relationship between them, we use these prefixes. As their name indicates, prefixes are put in front of units. And for example, if you see this one, for example, if you see this one, in the quantity of 6 centimeter, meter is the symbol of meter, and the letter C is the prefix called centi. So the prefix centi stands for 10 the power of negative 2. So thus 6 centimeter is equal to 6 times 10 to the power of minus 2. 10 to the power of minus 2 meter. Instead of centi, you can substitute by 10 to the power of 2. Are they equal or not? You can check again. You can check this one. You can check. If you check this one or if you convert it to each other, they give equal number or equal value of number. Equal value of number. So prefixes are the symbol of power of 10 and enter or put in front of what? In front of units or are put in front of unit, okay? Are put in front of unit. Yes? Huh? ይታያችኋል? አይታይም? ስክሪን ላይ ያለው
ይታያል።
እሺ so you can understand in this point again, in this point, what is the definition of prefixes? What is the definition of prefixes? What is their value? For example, kilo do have its own value or centi again, milli, and so on. And so on. Have you seen? Let's actually some prefixes and their value. Some in physics and their value. For example, prefixes, symbol, factors by which the base unit are multiplied. For example, before this, 8 GB. For example, when you talk about 8 GB, GB means bytes. G means it is a number. It is the number that represents 10 to the power of 9 or 1 billion. 10 to the power of 9 or 1 billion. So, Tera, not only this is one by not only this is one. For example, 10 to the power of 5, 15, 10 to the power of 1, 5, positive 1, 5, pita. 10 to the power of 18 is equal to eta. Eta. To the multiples, it continue. To the sub multiples, it will be continue. It will be continue. For example, Tera is a prefixes, which is the symbol for what? 10 to the power of 12. 10 to the power of 12. Again, eta is the units or the symbol which represent 10 to the power of 18. For example, for the negative again or for the very small number, for example, you can see femto, other, which is not mentioned on this table. Femto. Femto means 10 to the power of minus 15. 10 to the power of minus 15. Atto, for example, atto is the sum multiples which symbolize or which represent 10 to the power of what? 10 to the power of negative 18. Therefore, in case of these multiples, some multiples, it not includes this one. It is up to this one, and this one is starts from this one up to the bottom one. It is not included in this case, as it is visible on this shown on this table. Therefore, if you see up to deci, they are, we can call or we can rename by multiples, and from deci up to the end one, it is called sub multiples. That means they are very small number, and the above one are very large number, and they continue to the above and they continue to the bottom two. So you must know their symbol. For example, the difference between in case of prefixes and their symbol is small number. Have you seen small number and capital M and small m? Small m and capital M. Have you seen capital M represent or the symbol of mega. It is very big number, and the small m symbolized or represented by what? Very small number, what we call 10 to the power of -3 or 1 over 1000. So the difference between a small letter and the capital letter on this case, it may make difference. It may make difference, okay? It make difference. Therefore, you must know the difference between them. So the symbol of tera, T capital, giga, mega, kilo, hector, deca, deci, centi, milli, micro, nano, pico, again femto, atto, and zepto, and etc. At the top one again, pita, ita, yokta, and etc. They continue to the above and to the bottom. So these are some what we call prefixes. Prefix and the factors by which the base unit are multiplied. For example, if one person give for you 25 capital G or giga, this implies 25 times 10 to the power of what? 10 to the power of 9. Or if you write this one by scientific notation form, 2.5 times 10 to the power of 10. 10 to the power of 10. So giga, instead of giga, you can use 10 to the power of 9. 10 to the power of 9. As well as, for example, microampere. 2 microampere. 2 microampere. To express the current, you can use microampere. Very small number. Micro means 2 times 10 to the power of -6 ampere. Have you seen? Instead of micro, you can use 10 to the power of 6. 10 to the power of 6 -6. Sorry, 10 to the power of -6. This means 2 divided by 1 million. 2. For example, again, this one equal, if you want, 1 over 1 million. 1 over 1 million, 2 over 1 million ampere. This means, again, if you change or if you divide this number, 0.00002 ampere, I think. 1, 2, 3, 4, 5, 6. Yeah. So this is very small number, micro, picoampere again, picoampere, picoampere, 10 picoampere, 5 picoampere. We can say nanoampere again, milliampere. So by using prefixes, we can express again some small number and a very large number, So by using this one, we can write again, or we can change to another number or another unit. Do you have any question on this point again? Do you have question? Yes.
What is the smallest submultiple?
Yes.
What is the smallest submultiple?
I sorry. Pardon?
What is the smallest submultiple?
The smallest what?
Submultiple.
It continue, okay? It continue. If you take, it continue at the bottom again at the above. For example, is there the end of small number? Is there the end of small number? Is there? No.
No, Mr.
The number is continue. It is infinitive, isn't it?
Yes.
Numbers are infinitive. Therefore, because of numbers is infinitive, this can be again, it is infinitive, okay? When we write, we use some from them, we take some of them, okay? Some of them. In our daily activity, we use from them, some of them. So we will focus on which common one, okay? Have you understand what I wanted to say?
Yes.
Thank you. Okay. Let us see this exercise. I think it is visible for you very easily on your screen. Question number 1 writes 12 million watts, 1,000 meter, 0.00,01 centimeter, and then 0. Something by using scientific notation. By using scientific notation, try to write on this one. And on question number 2, what are the prefixes? Look, in this case, what are the prefixes used to write the number given below, A up to D, I up to D? Try to write this number for the first one by scientific notation, and the second one, what is the prefix we use for the given number? Try to write. Try to write. For example, shall we do for question number 1A together? Shall we do together?
No.
For A only. Yes. For A only. Let us do for A only. A, I think 12 million is what is given for you. Because of this large number, we count and we start from right and count to left. 1, 2, 3, 4, 5, 6, 7. Therefore, 1.2 times 10 to the power of positive 7 watts. Positive 7 watts. Or B, C, and D, try. Try.
ጥያቄውን አሳየን።
ጥያቄውን መልስ።
እሺ I think because of the time is up, we will continue at the next period, okay? Okay?
Okay.
Have you seen, by the way? You can copy up to the time is, I will give for you 2 minutes. Try to copy and try to, or try to take by screenshot if it is possible, and try by yourself. We will continue next period, okay? You will continue next period this question. Yes? Okay, therefore, in our today discussion, we have seen scientific notation as well as about prefixes, okay? About prefixes. Try this one by yourself, and we will continue next period, okay?
Okay.
Goodbye.
Bye.
I think you don't have a question.
Bye. Yes. Bye. Bye, mister.
Depending on what we have seen in our previous lesson. Question number 1 writes the given number by using scientific notation, and question number 2, what are the prefixes used to write the given number? Have you seen the question? Have you seen the question given for you? Have you seen? Have you seen the question given for you? Itayala?
Yes.
Itayal, question Itayal.
Itaya.
Let us see this question, how we can write by, for example, question number 1, using by scientific notation, okay? By scientific notation, and what prefixes used to write the given number, For example, for A, have you seen? We have done in our previous time. What about for B? For B? B. B, what is given for you? How many? B, have you seen? 1,000 meters. Therefore, look, 1,000 meters is equal to, when you write by scientific notation, 1 times 10 the power of 3 meter. Okay.
Screen ይታየም እኮ
Yes.
አይታየም።
አይታይም ጥያቄው።
አንተ ማትታየው
አንተ እኔን ሳይሆን ጥያቄው ይታያል ወይስ አይታይም?
አይታየም።
በቃ ስለ ጥያቄው ነው የምናወራ እንጂ ስለ እኔ ቪዲዮ አይደለም። Okay. Question number 1. See how we can write for this one. How we can write? Okay. Question number 1, for example, if you write this one by scientific notation, how you can write? For question number 1, how you can write? For example, 1, 2, 3, 4, 5, 6. Therefore, 0.00 is equal to 1 times 10 the power of -6. 10 the power of -6. Okay? 10 the power of -6 centimeter. 10 the power of -6 centimeter. Therefore, this one is equal to El Shaddai. There is sound around you, okay? El Shaddai and another. El Shaddai. Okay. Now, okay, I think. Shaddai, ከሷ ጀርባ ያለው ነው ታዲያ። Okay, sorry, others. Therefore, if you see this one, 10 the power of 6 minus 6 centimeter, okay? Yes.
አሁንም አይታይም።
አሁንም አይታይም? የትኛው
ጥያቄው አይታይም?
ጥያቄው እሺ wait me please.